Hello students, so the next video is on problems on Gibbs free energy and equilibrium constant, which you come across in the lesson again, electrochemistry. So you should know the equations, what do the terms mean here, and then we will solve the questions on it. So here the first equation for Gibbs free energy is given as change in Gibbs free energy is given as delta G naught equal to minus NEF E naught of cell, and here delta G naught is change in Gibbs free energy or Gibbs free energy change. N is the number of electrons lost or gained, and F is equal to 96,500 coulomb. We can relate Gibbs free energy and equilibrium constant. Already you have studied this equation in your first PU in the lesson thermodynamics as well as in chemical equilibrium, that delta G naught equal to minus 2.303 RT log K, where delta G naught is Gibbs free energy change, R is universal gas constant given as 8.314 joule per Kelvin per mole, T is temperature in Kelvin, and K is equilibrium constant. So you may get the questions in exam for 2 marks, that is problem on Gibbs free energy. So we'll try to solve the problems on this, that is Gibbs free energy, and then next we'll solve on equilibrium constant. So the first problem given here is calculate the value of delta G naught, delta R G naught at 298 Kelvin for the cell reaction. They have given this cell reaction, they have given E naught values. So why cell reaction is given? To find out which is anode and cathode, so that we can calculate E naught of cell, and N value also we can calculate. How do we calculate E naught of cell? Already discussed in the previous video. We calculate it as E naught of cathode minus E naught of anode, and here now we will calculate E naught cell equal to, so cathode here when you look at the equation, Mg changes to Mg2 plus means oxidation, so cathode, and here Al3 plus to Al means reduction, so reduction occurs at cathode and oxidation at anode, so Mg is anode, Al is cathode, Al value is so minus 1.66 volt minus of minus 2.36 volt, which is equal to, so when we calculate it here, what do we get? We'll check it. So minus into minus is plus, so we'll take it first. So 2.36 minus of 1.66, so what is the answer? We get 0.7. so here E naught cell value is equal to 0.7 volt, and here when you see the number of electrons lost and gained, 3 2 3s are 6 to 0 means 6 electrons are gained here, and 0 to plus 2, 3 2s are 6 means 6 electrons are lost here, so your N value is equal to 6. Now when we use the equation, what is the equation here? Delta R G naught is equal to minus NEF E naught cell. So we have N value minus 6 into 96487 coulomb into E naught cell value is 0.7 volt. So when you multiply it, what is the answer we get here? So we'll see it. 6 into 96487 into 0.7. So we'll check it once. 6 into 96487 into 0.7, which is equal to 4052 minus of 405245.4 joule per mole, and in terms of kilojoule, just shift the point by 1 2 3 digits, it is minus 405.245 kilojoule per mole. Remember to represent the delta R G naught value both in terms of joules and kilojoules. So we'll try to solve one more similar problem of the same kind. So next question given is find the value of delta G at 25 degrees Celsius for the following electrochemical reaction. They have done the cell representation, they have given the corresponding E naught values, and here we'll see. So first represented always will be anode on left side, next on right side will be cathode, means your copper is anode, silver is cathode. To calculate E naught cell, we know that we can calculate it as E naught of cathode minus E naught of anode. E naught cell equal to E naught of cathode is equal to 0.80 volt. E naught of anode is equal to 0.34 volt. So when you deduct it, what do we get? We'll check it. E naught cell is equal to 0.80 minus 0.34, which is equal to 0.46. So this is equal to 0.46 volt. Now here n value will be equal to, copper loses 2 electrons, silver gains 1 electron. So you can equalize it in a balanced equation by multiplying with 2. So it should be always equal. So n value becomes equal to 2. Now how can you calculate delta G? So delta RG naught ಹೇಗೆ ಬರೆಯಬಹುದು ಫಾರ್ಮುಲಾ ಮೈನಸ್ ಎನ್ ಎಫ್ ಇ ನಾಟ್ ಸೆಲ್. ಸೊ ಎನ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬಂದಿದೆ ಇಲ್ಲಿ 2. ಸೊ 2 ಇಂಟು ಎಫ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ನಾಟ್ ಗಿವನ್, ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಇಟ್ ಆಸ್ 96,500 ಕೂಲಮ್. ಇ ನಾಟ್ ಸೆಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೀವಿ, ಇಟ್ ಇಸ್ 0.46 ವೋಲ್ಟ್. ಸೊ ವಿ ವಿಲ್ ಮಲ್ಟಿಪ್ಲೈ ಇಟ್. ನಾವು ವೆನ್ ಯು ಮಲ್ಟಿಪ್ಲೈ ಇಟ್, ವಾಟ್ ಡು ವಿ ಗೆಟ್ ಹಿಯರ್? 2 ಇಂಟು 96,500 into 0.46, which we get it as 88780. So minus of 88780 coulomb volt is equal to joule, and here we'll take it as per mole. In terms of kilojoule, the same value for delta RG naught will be equal to minus of 887.80 kilojoule per mole. So this is the correct answer. So this is how you have to solve the problems on Gibbs free energy change. Next we'll see 2 more problems on equilibrium constant. How do we calculate it? So standard EMF of a cell and equilibrium constant are related by the equation E naught cell equal to 0.059 volt by N log Kc at 25 degrees Celsius. As we know already, E naught cell is standard electrode potential. N is the number of electrons lost or gained. Kc is equilibrium constant. And to calculate equilibrium constant, the above equation we can rearrange it as Kc equal to antilog of E naught cell into N divided by 0.059 volt. Now using this equation, either this or this equation, we'll solve the problems on equilibrium constant. Yes, we'll go with this question given. This can be asked as a 3-mark question. The cell in which the following reaction occurs. So they have given a reaction 2Fe3 plus 2I minus forming 2Fe2 plus I2 has E naught cell equal to 0.36 volt at 298 Kelvin. Calculate the standard Gibbs free energy change and equilibrium constant of the cell reaction. They have asked you to calculate delta G as well as Kc. So to calculate delta G as well as Kc, what you need? E naught cell, which is already given, and even you need En value. So when you look at the equation, plus 3 to plus 2 means there is a gain of 1 electron, and minus 1 to 0 means there is a loss of only 1 electron. So your En value in this case is equal to how much? 1. So we'll solve first Gibbs free energy. So what's the equation for Gibbs free energy? We know that delta RG naught equal to minus NF E naught cell, which is equal to minus of N value is 1, 96,500 because F value is not given, and E naught is 0.36 volt. So here delta R G naught becomes equal to, so when you multiply it, what do we get here? 1 into 96500 into 0.236. So it is equal to 22774. So 22774 volt, coulomb volt, which is nothing but joule per mole. And in terms of kilojoule, the same we can write it as delta RG naught 227.74 kilojoule per mole. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಯಾವಾಗಲೂ Gibbs free energy ಬರೆಯುವಾಗ you have to mention both unit joule and kilojoule. Next we'll go with equilibrium constant. So the equation to calculate equilibrium constant we had written as E naught cell was equal to 0.059 volt divided by N into log Kc, where Kc is your equilibrium constant. Idanna rearrange ಮಾಡಿದಾಗ we get it as Kc is equal to antilog of E naught cell into N divided by 0.059 volt. So ಇಲ್ಲಿ ಏನಾಗ್ತದೆ? Kc is equal to antilog of E naught cell value already it is given. It is equal to how much here? 0.236 volt. We'll substitute it. 0.236 into volt into 1 divided by 0.059. So what we get here? We'll check it. Antilog of 0.236 into 1 is 0.236 divided by 0.059, which is equal to 4. So here you get the value as antilog of 4. So antilog of 4 is nothing but 4.0. So Kc becomes equal to whatever is before the decimal point and to the power 4. So Kc value is equal to 10 to the power 4, and hence the correct answer is 10 to the power 4. Next, we'll go with calculate the equilibrium constant of the reaction. They have given a reaction, they have given E0 cell value. To calculate the equilibrium constant, the equation what we use is E0 cell equal to 0.059 volt divided by N into log Kc. So Kc equal to anti-log of E0 cell into N divided by 0.059 volt. So in E0 cell value kottidare, N value when you look you can find out 0 to plus 2, 2 electrons are lost, plus 1 to 0, plus 1 into 2 is 2. So 2 to 0 means 2 electrons are gained. So your N value is 2, will substitute it. Kc is equal to anti-log of E0 cell value is 0.46 volt into 2 divided by 0.059 volt. Now when you simplify it, so when you simplify it, what you get? 0.46 into 2 divided by 0.059. So when you divide it, you get it as 15.593. So Kc is equal to anti-log of 15.593. Whatever you have before the decimal point, you write it as 10 to the power 15, and 0.593 we find it out in anti-logarithmic table. So we'll find it out. So in anti-log we were left with 0.593. So here 0.59 is here, and 3 means 0, 1, 2, 3. It is 3917. So we'll write this value here. 3917 into, so it is 3.197 into 10 to the power 15. So it is your Kc value. Kc is equal to 3.917 into 10 to the power 15. You can solve other problems. If you have any doubts, you can post. So thank you for watching. All the best for your exams.